All right, here's problem 2. This problem is pretty much the same as problem 1. We toss a ball directly upward with a velocity of 10 meters per second. So how high does the ball go? What is the total time it's in the air? And what's the speed of the ball when it returns to its initial position? So I'm going to draw a picture. And so here's a person. And then I'm going to make a coordinate system. And my coordinate system, it's centered on where that ball starts off. It doesn't have to be. Any coordinate system will work and give you the same answers if you're consistent about it. And so in this case, it's convenient to put the origin right where that little ball starts off, right? And so here we know that V naught is 10 meters per second. We know the acceleration is the acceleration due to gravity. So for this problem, down is the negative direction. So I'm going to set acceleration at minus 10 meters per second squared. And oh my gosh, now we're not given any more information. That's okay. You could still figure this out. So for example, how high does the ball reach? Well, and then up here it stops, all right. So I know something about the motion of the ball up here. If it stops, that means its velocity at the highest point is 0 meters per second. So for figuring out here just how high it's going to go, let's say V final is 0 meters per second. And I'm looking for delta Y. We already know what delta Y is, don't we? Yeah, it's going to be 5 meters. But let's go ahead and do this with math. So the one item here that we don't know is how long it takes to go up and stop. We don't know the time that it's in the air. We could figure that out. In other words, you could do part B before you do part A, but you don't have to, because we have another handy-dandy equation in our list of equations that looks like this. It's V final squared is equal to V naught squared plus 2A, in this case, delta Y. Yeah, we can use this because we know all of these variables except for delta Y, which is what we're looking for. So V final at the very top is 0. So I'm going to do this without the dimensions initially because that might be confusing you or make it look more cluttered. So V naught is 10 meters per second. That's given. So it's going to be 10 squared plus 2. The acceleration due to gravity is minus 10. And again, we're leaving the dimensions off here. And then we're looking for delta Y is what we're looking for here. So then let's do some more math. So 0 is equal to, well, 10 squared is 100. 2 times negative 10 is minus 20 times delta Y. And so 100 minus what is 0? Well, 100 minus 100 is 0. So 20 times delta Y has got to be 100. So 20 times what is 100? Well, 20 times 5. But that was all very, very fast. So let's do this algebraically. Let's add 20 delta Y to both sides. And so here, adding 20 delta Y to both sides, it cancels out that term. So now I have 20 delta Y is 100, divide both sides by 20. So delta y is 100 divided by 20. And 100 divided by 20 is 5. Dimensionally, let's go back and put these dimensions in because it's going to drive me crazy. So 0 is equal to 10 meters per second. That whole thing is squared. Then plus 2. The acceleration is minus 10 meters per second squared times delta y. So look at what happens with these dimensions. 10 squared, the number part is 100. And when I square meters over seconds, that means this is meters squared over second squared. And that's minus 20. And I have meters over second squared. But this is times the units of delta y. Those are meters. So here I have meters per second squared. Meters times meters. That's meters squared over second squared. Meters times meters is meters squared over second squared. So dimensionally, that's consistent. Yeah, it goes up 5 meters. All right, and then what is the total time the ball is in the air? Well, again, it's losing 10 meters per second of speed every second it's in the air. So it started off with a speed of 10 meters per second. It takes 1 second to get down to 0. Or we could do this. How about V final is equal to V naught plus A times T. So V final was 0 meters per second. V naught is 10 meters per second. Plus A is minus 10 meters over second squared times T. So then this becomes, and again, let's just go ahead and leave the dimensions here off momentarily. So this is equal to 10 plus minus 10 plus times minus 10 minus 10. So 10 minus 10t is 0. Well, 10 minus 10 is 0, so t's got to be 1. But the algebra, let's add 10t to both sides. And that cancels out that 10t on the right. So now I have 10t is equal to 10. Divide both sides by 10. So then t is equal to 1 second. Right? And then dimensionally, I have okay, yeah, so t, that's measured in seconds, right? So one of those seconds cancels out with that guy. So I've got meters per second minus meters per second. And then you can subtract those two. So 10, and I end up, that's meters over seconds. It's not meters over seconds. Now I'm confusing myself. Let's start over here. Sorry. See, that's why I always leave the units in. Okay, so V final. I know I'm confusing you more than I'm confusing myself. Is V naught plus AT. So this is 0 meters per second is equal to 10 meters per second, and this ends up being minus 10 meters per second squared times t. Because I'm looking for t, yes? And so then let's do this. Let's add 10t to both sides. So then I have 10 meters over second squared times t is equal to 10 meters over seconds. All right. And then divide both sides by 10 meters per second squared. That's more like it. So dividing both sides by 10 meters per second squared, well, on the left, that 10 meters per second squared goes away. 10 over 10 is 1. And look at now what happens with the dimensions. Meter over meter, that cancels. 1 over seconds divided by 1 over seconds squared, believe it or not, one of those guys cancels out. And this seconds comes back upstairs. So there you go, 1 second. And then by symmetry, if it spins a second moving up in the air, so t up is 1 second, then it's going to take 1 second to come back down. So the total time in the air is 2 seconds. And the speed of the ball when it returns to its initial position. Well, 2 ways of looking at this. One is this symmetry principle I mentioned. If it's tossed up in the air with a speed of 10 meters per second, when it lands at the same position, it's moving 10 meters per second, except it's going downward. But look, check this out. Toss this guy up in the air so that we have a V naught of 10 meters per second. And we want to find V final. Well, yeah, there's an equation for that. That equation is V final is equal to V naught plus AT. So V final is equal to, well, my V naught was 10. Plus, the acceleration is minus 10 meters per second squared. And the time for the whole trip is 2 seconds. So that leaves me with 10 meters per second minus 10 times 2 is 20. And then that seconds cancels with one of these guys, so minus 20 meters per second. 10 minus 20. Wait a second, that's not a positive number. That's fine. The ball's moving down when it lands, so it makes sense our answer comes out negative. So minus 10 meters per second. Oof. That's a lot of stuff. And so that's good for that problem.